Okay, this is from section 7.4, number 2, and we arc length formula to find the length of the curve. So let's see, our arc length formula is going to go from the square root of 1 plus the f prime of x squared, right? Okay, so f prime of x. So f of x is what? 2 minus x squared. Okay, so to the 1/2. So f prime of x will be 1/2 2 minus x squared to the negative 1/2 times negative 2x. So I'm going to simplify that a little bit then. Just kind of rewrite it. So that's going to be negative x over 2 minus x squared, square root of that, right? Negative, yes. Okay, now if we square that, that's going to be x squared over 2 minus x squared. All right, so our interval then, and that goes from 0 to 1, will be from 0 to 1, the square root of 1 plus x squared over 2 minus x squared dx. And 0 to 1. Now I'm going to go ahead and get a common denominator. So that's going to be 2 minus x squared over 2 minus x squared plus squared over 2 minus x squared. So when I simplify that, notice the x squared is giving me the 0 there, so we're just going to have 2 over 2 minus x squared. And let's see, so that's going to be the square root of 2 times the integral from 0 to 1. So I'm just taking that constant out. All right, so let's see. So I'm going to do a trig substitution here. And u is going to be the square root of 2 times sine of x. Because I have this in here, remember, this is 1 over square root of 2 minus x squared, right? So it kind of has that look to it. Something squared minus x squared. And then du is going to be square root of 2 cosine of x. Then we'll have to switch our bounds. So my lower bound, 0 would have to equal square root of 2 sine of x. So sine inverse of 0 is going to be our x, which means what x is going to be 0. And for the upper bound, we're going to have, stop that, 1 equals square root of 2 sine of x. So sine inverse of 1 over square root of 2 is going to have to equal x. So that happens when x is equal to pi over 4. So we're going to have our interval from 0 to pi over 4. So now when I make those substitutions then, we'll go from 0 to pi over 4. We'll just have that square root of 2 out here. And that's going to be 2 minus 2 sine squared of x to the negative 1/2. And the dx is times square root of 2 cosine of x. X. Now, I probably should have used a different variable instead of x's, to be honest. I should have put x equals sine of u. Okay, so not to get kind of confused, and that would be dx cosine of u du. So let me just kind of fix those so I don't get all crazy. So let's see, that would be u, and sine of u squared, cosine of u du. Okay, so I got my variables fixed to give myself a little peace of mind there. So that's going to be 2 times the integral from 0 to pi over 4. Now, just to emphasize, the square root, that's going to be 1 minus sine squared. If I factor out the 2 out of that, times, and then we'll have cosine of u du. So all I did here was write this as 2 times 1 minus sine squared of u. And of course that had all the square root, and then I just pulled the square root of 2, or that is, the product up front. So again, I'm going to make 2 steps here. I'm going to pull this square root 2 out here, and that's going to give me 2 divided by the square root of 2, right, is just square root of 2. To me, cosine of u. Now, this piece is cosine squared of u, right? And we take the square root of that, we're just going to get cosine of u. And now I need a little bit more room, but cosine over cosine is just 1 du, right? So that makes the integration really super easy. And why did I put square root of x? So that's square root of 2, and that's just going to be u evaluated from 0 to pi over 4, and that is going to be what the square root of 2 times pi over 4 is going to be our arc length.